So, in your book, on page page 565 is a really crappy table. Why they didn't put that in the back of the book, I do not know. But the fact of the matter is, I'm going to give you guys a much better table. And I will show you that as soon as my computer comes up.
What page is it on?
No, what did I say?
565.
565, that sounds right. So that's the crappy table. Yeah, 565 is your table. That's probably the table that the book uses. Now, one of the problems with this is that you cannot find a p-value from the table unless you get that exact value. Okay? But the table that I'd rather have you use, I think I already posted. Remember your normal table? There was another table that you've been ignoring until now? It's that table there. So, I'll show you how that works. So the idea here is, didn't we get 1 point, so in our last one we got chi squared equals 1.55, your degrees of freedom equals 1, right? I think that sounds right to me. Now hopefully, this computer will hurry up. Now we'll pull that up. Actually, okay, here it is. We'll pull this up here. So if you're using and you'll need to know how to use this table as well. So I can either give you the one book or this one, but this one's a much better table. I'm glad you asked me this question. I wish my computer would go faster. Okay, so I just posted this up on assignments. On the bottom, you've got Excel examples. And down the bottom, I've got chi-squared independence test. Okay, so this is what we just did downstairs. And all that's counted. Okay, so here's your chi-squared distribution. Okay? Okay, we're going to go to the table. Okay, so here's the problem. Okay, first of all, let's look at this, because this is a much better table, but it's a little bit more complicated. Okay, so when you're looking at your table, this is a chi-square distribution. You've got an alpha here. So the table is telling you the area to the right. Okay? Now, I'm going to keep it simple for now. So the idea here is we got a value of 1.55 and a degree of freedom of 1. So as we're looking here, if you want to figure out your p-value, okay, with this, all you can do is you can bracket it. Okay, your p-value is going to be between two values. So as you're looking along here, degrees of freedom is 1. You're looking for where does 1.55 fit? It fits in between those two numbers there. So that means that it's in between those two numbers there. So it's somewhere in between 0.10 and 0.90. 0.10 and 0.90. That's as good as you get. Now, the true answer we got was the p-value was 0.21, which is in between 0.10 and 0.90. So this table is kind of lousy that way. So if you want to get an exact p-value, the only way to do it is with the computer. If you're using the table, you're going to bracket it somehow. Does that make sense? Okay? And that's a pretty lousy bracket. But in either case, if your alpha is 0.05, you can still compare 0.10 to 0.5. That's still going to say do not reject, which means that gender is independent of admission. Now, you can do it with their table too, and you should get a similar answer. But they don't even have all the stuff there. Okay? Actually, theirs is a little bit different. On their table, you can say that your p-value is between 0.20 and 0.25. Maybe they have a much different table. Okay? So theirs you can bracket it a little bit better because they don't have these columns here, and they've actually added a few more on the low side. So either way, you should know how to use either table. I think it's a little bit better table. Okay? All right. So now, do you have any questions before we take our quiz? And if we have time at the end, we'll do one more example from the book. Yes?
Just to go over step 4 of finding the p-value, with if something is greater than or less than, the alternative is greater than or less than.
For proportion or for?
Or
Okay. So finding a p-value, so do you have a z-score?
no, that's just the part of this practice. I don't have my book with me, I don't remember which
Okay.
question it was.
So in order to find a p-value, you gotta either have a z-score or a chi-square value. So I can make one up. What do you want your z-score to be? Make up a number. What?
0.5.
0.5. Z-score equals 0.5. Now, you need actually more information now. What's your null hypothesis? And your alternative hypothesis? It can be anything you want, we're just making it up.
No hypothesis equals
Mu equals 10. And your alternative hypothesis is mu is greater than 10. Okay? Or do you want the two-sided one?
I don't care, I just think.
I think you did want it. You wanted the two-sided one. We'll make it not equal. Okay? All right. So you've got some mean is 10. You've got some mu does not equal 10. You get a z-score of 0.5. Okay? We're using the z distribution, so I'm not using the chi-square anymore. Do you want to do it from the normal table? Okay? So, I'll try to make this a little bit bigger. Okay? So, in this case, I need to find 0.5, right? 0.50, so I'm going to be looking in this first column. 0.50, the value here is 0.6915. Do you see that? Now, this is where the picture comes in really handy. What's going on with the picture? This is a crappy pen. We've got a nice normal distribution, it's symmetric. What should the mean be? Huh? 0. And I got a z-score of 0.5. Okay, I'm going to draw a line here. Now, when I look at 0.5 here, it gives me the value of 0.6915. So is that the area on the right or on the left? This is the area on the left. What area do I want? I want the area on the right. So what is the area on the right?
1 minus 69.15.
1 minus 0.6915, which equals 5 minus 8, 385. Okay? But we said that this was a two-sided test, didn't we? It's not equal to. So is this the right answer?
Yeah, it's
No, I
1
get to
divided by 2.
multiply that times 2. 0.7770. So because basically what that means is, okay, I'm going to erase this. I got to go over here to the negative 0.5 as well, and I want this area as well. So this area here is 0.3885. This area here is 0.3885. I add them up and I get 0.7770. Okay? Now I only multiply it by 2 if it's a two-sided test. If it was one-sided, I would just take it as is.
How do you know if it's two-sided?
For your alternative hypothesis. If it's not equal, it's two-sided.
If it's-
Two-sided. If it's a greater than or less than, it's one-sided. Okay? All right, you ready for your quiz? You're out of time, but I'll take it.